So in the next question, it says a hot plate of an electric oven connected to a 220 volt line has two resistance coil A and B. So there are two resistance coil and these coils are A and B and each of 24 ohm resistance, which may be connected separately. That means case 1 separately, case 1 separately, case 2 in series and case 3 in parallel. So finally what we have to get is the current in all three cases. So there are three cases as you can figure out. Number one, when they are connected in series. Number two, when parallel. And number three, when they are connected separately. So what I'm going to do, let's say if I make a circuit, well, to understand this, well, technically we don't need to make in the exam. So I'm going to place here a battery. I'm placing a battery, say, or a cell. So this being positive, negative, right? Connected a battery. Now I'm going to make three resistors, say, sorry, two of them. We have a two resistors. So one is this and the other, and they are of equal resistance as you can see from the question is given that they are of equal resistance. So see, this is the resistor 1 and this is the resistor 2. Now check what they are saying, that if each of this case 1 when they are connected separately. So as you can see, I have connected this resistor separately and its resistance is given as 24 ohm. So I'm going to first find out the current in the case 1 when it is connected separately. Further, we know that there is a voltage supply of 220 volt. So let's find out I. We know that relation V is equal to IR. So I is equal to V over R. And how much is V here? 220, and that divided by 24. So this is case 1, right? So we'll divide 220 with 24. On reducing, you will get this as 9.16 ampere. Now case 2, when they are connected in series. So I'm going to attach the other resistor here and they are connected in series. Let's say I attach it over here, this resistor, and the resistance of this also is how much? 24 ohm. So first what I'll do, I'll find out the total resistance of case 2. Well, case 2 I'll do here, let's say here. So I can say that these resistors are connected in series. So the total resistance is what? 24 plus 24. So R comes out to be how much? 48 ohm. And then in the same manner, we'll be calculating I. I is equal to V over R, and V is 220. That divided by R as 48. So this time it will be half, right? That was, 220 divided by 48 will be half of the previous value. So it should come around 4.58 ohm, not ohm, ampere. So now once again, this is the answer for the first part. If I need to color it, and the answer for the second part is this. Okay. Now in the next part, what they are saying that these registers, we have done two parts, right? We have done the first part of separately and series, and now I'm going to find out when they are connected in parallel. So now I need to connect these two resistors in parallel. Let's say if I bring down this resistor below and I'm going to connect them in parallel. Wait a second. So first I'll connect this. I'll erase this and we'll connect this through a wire. Right. As you can see now, these two resistors are connected in parallel. So let's figure out how much is the resistance, total resistance. This is 24 ohm. So we have done two cases. Now I'm going to do the third one here. So for doing the third one, I'll use this space here. Now, what we know that when two resistors are connected in parallel, the total resistance is what? 1 over R1 plus 1 over R2. So I'll say 1 over R is equal to 1 over R1 is what? 1 by 24 plus 1 by 24 should give you 2 by 24, and 2 by 24 is what? 1 by 12. So R comes out to be 12 ohm. And then since we have to find out current, that is same way, we'll be finding I is equal to V over R, and V is 220 divided by R, which is 12. So it should be double of this first case. 220 divided by 12 should be, yeah, it's double. It is coming as 18.33. So we got this. Now I can now say that this is for the first part when they connected separately. This is the current in the second part when they were connected in series, and this being when connected in parallel. This is the case for the third part. Right. Let's move to the next question. In the next question is a battery of 9 volt is connected in series. Right? They are connected in series with resistors. Okay. Of these are the resistance of 5 such resistors respectively. How much current would be drawn through 2 ohm resistor? Now what we know that when devices or resistors are connected in series, the current remains same. So if irrespective we are asked to find out the current across this, or this, or this, or this, is going to be same, right? As you know that current remains same in series, and these are connected in series. So what we'll do, instead of calculating the resistance across 2 ohm, we are going to calculate the resistance of the whole circuit. One more time, we need to figure out first thing that when the resistors are connected in series, the current remains same. So current remains same irrespective across this, or any other. And that is the reason we are going to calculate the total current here. So for that, we know the total voltage, but then we have to calculate the total resistance. So as you know that when devices are connected in series, the total resistance is what? R1 plus R2 plus R3. How many resistors are there? 1, 2, 3, 4, 5 plus R4 plus R5 here. So I can say it's 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. So this is how much? This is 3, 2, 5, 5, 1, 13, 13.4 ohm is the total resistance. And as I said in the beginning that we will be applying V is equal to IR, and that implies from here that I is equal to V over R. So I is what we have to get. And how much is V? V is mentioned as 9 volt. So 9 divided by 13.4 ampere. So you should get this in decimal as a final answer. Now in question number 10, it says how many, we have to find the numbers of 126 resistor. That means each resistor is of 126 ohm when connected in parallel, are required to carry 5 ampere current, right, on a 220 volt line. So we have to find the number of resistor, right? The number of resistor is what we have to get. The first thing that I'll do is using V is equal to IR, I'll find the total resistance in the circuit. So from here I can say R is equal to V over I, and how much is V? V is 220, that divided by I, and what is I here? 5. So if I reduce 44 times, so we got the total resistance of the circuit or equivalent resistance. Now, what else we know that when resistors are connected in parallel, the total resistance or the equivalent resistance is what? 1 over R is equal to 1 over R1 plus 1 over R2. Check here, I'm not writing R2, I'm writing R1 again, as we have same resistance, right? Right, as you can see, all of them has the same resistance, plus 1 over R3, and so on, so on, so on. Now, if I say that there are 3 resistors, you will say 3 by R1. You'll say 3 by R1. And if I say n number of resistors, right, connected like this one more time, If I have two resistors of R1, you'll say 2 by R1. If I have 3, you'll say 3 by R1. If I say n number of resistors, then it is n by R1. Now what we know here, we know the total resistance of the circuit, which is 44. So I'm going to replace R with 44. And for each resistor is what? 176. So I'll be replacing R1 with 176. So next is cross multiplication. So n will come as 176 divided by 4. Sorry, 44. It's coming as 4 only. So n is equal to 4. So our final answer should be there are 4 such resistor. We'll write this as 4 such resistor connected in parallel are required to carry a current of 5 ampere in a 220 line volt. In this question, we are given a circuit diagram, as you can see. And what we have to find out in the first part is the total resistance, or say equivalent resistance. The first thing what we are going to do is to look into these two. We can clearly see from here that these two are connected in parallel, right? So first I'm going to find the equivalent resistance across these two, right, over here. So as I said, they are connected in parallel. So I'll say that the resistance here, if I use R dash, is what? 1 over 5 plus 1 over 10. It should give you 1 over R dash as 2 plus 1, 3 over 10. Right, so R dash comes out to be 10 over 3, or you may write this as how much? As 3.33 ohm. Now let's see the other resistor. This resistor is connected with this R dash in this R dash is this whole, right, with series, right? They're connected in series. So I can say now the total resistance, say R, will be what? 7 ohm plus R dash, which is how much? I'm going to take the fractional value instead of this. So the total resistance is what? 21 plus 7, 21 plus 10, right? So 31 over 3. So we get the total resistance over here as 31 over 3. Now that's the first part. Now what we have to get in the second part is to total current, right? The total current. So we'll apply V is equal to IR to get the total current. So we'll write V is equal to IR. We can see that the battery supplying a potential of 6 volt. So replacing V here with 6, and I is what we have to get, and the resistance, which is 31 over 3. So I will come as what? 6 into 3, 18 over 31 ampere. Now moving to the next part and the last part here, what does we have to get is the voltage across this. The voltage across this. Now we can see that here this 7 ohm resistor is connected in what? It is connected in series. So therefore here V, say if I use V1 here I R1. And why I1? Because I remains same. So V1 is equal to I, which we has got as 18 over 31, that multiplied by 7. So we'll say that V1 in this case should be 18 multiplied by 7. So I can see that these numbers getting reduced here. So we'll simply multiply 18 with 7. It comes out to be 126 over 31. So we may divide it by 31 to get the total resistance, voltage that come across around 4.06 volt. So we'll say that this is the voltage for the 7 ohm resistor. In this question, it says a wire of resistance 20 ohm is bent in the form of a closed square, and we have to find the resistance across the diagonals of a square. So let's say if I make a wire, let's say this was the original piece of wire, and its resistance is given how much? It is 20 ohm. And the same wire is bent in the shape of a square. right? And what we have to find out is the resistance across the ends of its diagonal. So that means we are going to connect this ends of this wire, sorry, diagonal, with a battery. Well, as I say, diagram is not necessary but we do so for the clarity. Now here, as such, there is no wire, right? The diagonal, I just made it to indicate that we are looking for resistance across these BD end. Now, what we know here that resistance is directly proportional to the length. So can I say that since this wire, whatever its original length, say L, now is split into four equal parts like this, each side, say AB, AD, DC, BC will be 1/4 of the original length. So since resistance is directly proportional to the length, I can say that the resistance of each wire, say R dash, if I use, will be 1/4 the original resistance, which was 20 ohm. So this is 5. So I can say this is 5 ohm, 5 ohm, 5 ohm, and 5 ohm. Next, check for this end AB and AD. They are connected end to end, right? They are connected end to end. So if I say what is the resistance across this, the total resistance, it should be they are connected in series. So I'll say if I use R dash for this, it should be 5 plus 5. So R double dash is how much? 10 ohm. Am I right? Yeah, it should be. Now, similarly, these two ends, that is BC and CD, are connected end to end. So here too, we can say that the total resistance, say if I use R triple dash, will be what? Again, 5 plus 5, that is equal to 10 ohm. Now, the next and the important part here is that if I talk about how is this whole this is connected with this end, say this end, right? So they are connected independently. As you can see that on wiping out any wire, if I wipe out this part, it does not affect the current flow in the other part. And vice versa, even if I wipe out this part, current continues to flow on the other end. So we'll say that they are connected in parallel. And in that case, the total resistance, if I have to calculate, I'll say 1 over what I use, say R4, I can, or RP, whatever. It should be what? 1 over 10 plus 1 over 10. It should give you how much? 2 over 10. So 2 over 10 is what? 1 over 5. So we'll say finally the resistance, we'll finally say the resistance, total resistance in the circuit will be of 5 ohm. So this should be our final answer in this case. In this question from the chapter electricity, as you can see, a diagram is given over here, and there are three bulbs, say B1, B2, and B3 are connected in parallel, as you can see. And then there is a battery of 4.5 volt. Now, what we have to find out in the first part is what will happen to the power, oh, sorry, what will happen to the glow of the other bulb if B3 is fused. So you can see that these bulbs are connected in parallel. So even if B3 gets fused, like if I wipe out B3, as you can see that the current continues to flows in the other device, I mean other bulbs. B1 is connected like this. You can see from here only. That is, we say this end of the B1 is connected and this end of the B1 is also connected. Same with the B2. So we can say that there will be no change in the brightness. Well, the answer should be no change. So that's no change in the brightness of the bulb. Now coming to the next part, it says if the wattage of the each bulb is 1.5, how much reading an ammeter A shows when all the three bulbs are glowing simultaneously? So let me write down the wattage here. We know that for the bulb 1 here, the first bulb, the wattage, say I use W1 as 1.5, not 1 W, it should be power, right? So we'll write P1 is equal to what? 1.5 watt. For P2 is same, it is 1.5 watt, and so is P3, which is 1.5 watt. Now, what you know that when devices are connected in parallel, the total power, right, the total power will be equal to the sum of their individual power. That is, I'm talking about power, not resistance, right? And this is the case when the devices are connected in parallel. So it'll be 1.5 plus 1.5 plus 1.5. So the power should be how much? 4.5 watt is the total power of the circuit. But then we are looking for the reading in the ammeter, that is current. So we are given voltage here. Voltage supply is how much? 4.5 volt. So using Ohm's law, that is V is equal to IR, we can find I is equal to V over R. So how much it should be? V, which is 4.5. Or we have to get what? Oh, we are not going to use this formula as of now. We are going to use P is equal to VI, right? We have to get I. So replacing P with its value, which is 4.5, and V, which is 4.5 again, from here, we get I here. I should be what? I comes out to be 1 ampere. So in the first part, what we got? We got the total power, and we got the total current, which is the reading of the ammeter. So we can say the answer for the second part will be 1 ampere. Now check for the next part, the last part. It says find the total resistance of the bulb. So here we are going to apply the relation, that is V is equal to IR. So V is equal to IR. We know V, which is how much? 4.5 volt, and current, which we have calculated as 1 ampere, multiplied by the resistance. So clearly R comes out to be 4.5 ohm. So that should be the answer for this part.